So we're going to look into how we can implement standard design pattern with Kotlin. As you know, design patterns are basically wait form cookie cutter way of writing the code for specific problem area that will help us to manage and extend and maintain our progress. So in this is the first session on this. Today we're going to look into the classical pattern, and on the classical pattern we're going to be looking into our creation patterns that we have previously looked into, and also our structural pattern. And the next session we're going to be looking into reactive or concurrent patterns. How can we use most probably Kotlin support coroutines? How can you create those reactive and concurrent patterns for coroutines? Then we're going to look into which patterns, what is anti-patterns, and also how we can use the design pattern with microservices. That is for today's objective. This is the classical patterns. One is for structural, one is for creational, and the sample code for that. Okay. Any question on the coverage?
No question.
Okay. Classical pattern, as we know, are broken down into three parts. So let's look into creation patterns. So creation patterns is basically this 5 patterns. What are creation patterns? Creation patterns are nothing but the patterns which are used to create objects, right? So these objects are being created without being creating a new construct. There are different ways we can create the object without just simply using the constructor that is there. The first of them are, as we well know, are Singleton pattern. Okay. So in the Singleton pattern, what happened is that you're going to be wanted to access a particular resource, right? And you want only have just a single instance of that resource to be presented. For example, I wanted to have like a database connection. Only one database connection or a pool of database connection may be open. Maybe, for example, a simple example is I wanted to create a log, right? So from my application, I wanted to create a single instance of log that I'm going to use in all my classes. I'm going to log the request, response, and other thing that is there. Okay, and that particular object will encompass to doing a particular activity, but it will provide a global access. So that particular single object can be accessed by everybody else. Now this pattern though solves the problem, but it also violates the single responsibility principle that only one object going to be responsible for only one activity or one responsibility. But it is here is a global. So how we can ensure the single instances? I think we know this pattern. There are certain consideration we have to do. Like for example, we have to also ensure there are like thread safety. Multiple concurrent threads are there, and there should be only one object being created. Similarly, this object are not being cloned, and there can be not be duplicate object be created. So that means it should not support prototype pattern. Okay, let it create another clone of this object. When that breaks the functionality, and it will create another object where within my system there will be just a single instance of that particular object will be there. Now, how to implement this pattern with Java? I hope you guys know how to implement this. There in Java, what we basically create, we make the constructor private. We create a static method, say get instance or get object, whatever, and we create the instance object, and we just in the instance object we check there is like a instance method is there and there is no pattern. a single object is there. To handle multi-concurrency, we can put any kind of log that is there, that is provided by out of the Java that you can use. And also the clonable interface clone method are not supported. That's how we generally implement that in the Java code. Now let's see. So that means this particular object will be shared across different part of the program. All our client will be having this, right? And also using singleton pattern ensure that you have like stricter control over this global object or variable, or not just variable, it's a immutable type. You get only one object, so only one instance will be accepted, and that it's been single instance. Okay. And the benefit of this pattern is that your class only going to have a single instance, and you gain the access point, a global access point within your class to access that. And single instance object are initialized only once when it's first requested, right? But what is the cons of this? Is violate single responsibility principle, and singleton pattern is kind of like a bad design for say. For instance, as when you want the component, other client need to know about the singleton object, they need to be aware of. And obviously for multi-threading, you need to provide additional support. And also it's very difficult to unit test cases rather than, because here your constructor is being the private and etc. And singleton design pattern is also being used with other design pattern. For example, a packet class can be implemented as a singleton design pattern. Flyway can resemble a singleton pattern. Okay. Abstract factory builders and prototypes also can be implemented as a singleton pattern also. Okay. So let's see a simple example of singleton pattern. How can I with Kotlin? So here is my creation patterns. First is a singleton pattern. So what is happening in the singleton pattern? So here the purpose is I just wanted to have a single instance or log, right? So that means I got to only wanted to have like a global logger object that I can use in my all the classes. It can have like here we have shown log method. It can have info, it can have debug, it can have trace, it can have errors, other log labels, right? So what you can do, we can use the object keyword to ensure that it's like a logger object, single object being created. Okay. There is no separate class. You just put object, then the logger, and any kind of initialization you can do it within the init block of code and the other methods that is there. So if you wanted to use this, you can simply use the logger.log hello world. And just simply execute and create hello world out here. Okay. So no question, I guess, on the singleton pattern. How can I do using Kotlin? Just use the object keyword. Now the next design pattern that we have out here is the prototype pattern. So what is the prototype pattern? So prototype pattern is another creational pattern which let you create a object or make a clone of one object. Okay. Now fine. Where we require this cloning of object, when you want to create a copy of another object, maybe I wanted to do that. And so, okay, but When you're going to be cloning this, are they going to be writing a separate code into another class? No, you're going to be writing the code in that particular class. Okay. So what is the problem it solves? So problem it solves, say you have an object, right? You wanted to have a like an exact copy. Exact copy means you wanted to create a deep copy. This means this object have a certain nested object and that particular state you wanted to copy. So how are you going to do that? You may wanted to create the object. You're going to be then copy over the single values one by one, right? And the problem with that is some of the variables may be private, may not be visible from that particular object. Then it's become difficult to make a copy of that. Okay. And with this particular direct approach that you create a object, you create another class, then you copy over the each of the values, right? Is that not all the values will be initialized, right? Sometimes the some of the instances are there, okay, or maybe some objects are not actually object rather than interface. So in that case, how we're going to be initializing that? So for these purposes, we have the prototype pattern. Now, instead of who going to be taking up the creation of the actual object, it is the object that will be cloned will be having the delegation of creating a clone of that particular object. Okay. So how this pattern is implemented? It basically declares a single interface. For example, we know in Java we had the clonable interface, right? And in the clonable interface, you have a clone method. So if you want to make a clone, you just of one object, you just call the clonable method. Clone method provided your class is implementing clonable interface, and it is the implementation of that particular clonable method will be provided by the class that you wanted to, that class object you wanted to make a copy of. Okay. So the logic is encapsulated within the class. Now it is up to the class if the object fields are private, right? So that problem will not be there if they're been implemented within the class. Okay. And then the object is been, we can say, is supporting, other class is been supporting prototype patterns. So there is no need for a subclassing to go over that particular limitation of direct approach. You can just have a single class and you can do the prototyping of that. So how are we going to do that? So we're going to create one instance, okay, and in that instance we're going to have like a clone method that is returning. Say we can call this as a prototype interface, and that's going to be return a prototype value, right? Then we have to create a concrete class. In the concrete class, you're going to be having prototype. It is implemented. Or further, you can have another subclass where you're going to have the prototype implemented. That is like a kind of like a basic implementation. So all the client is need not to be doing is the creation of the object and copy it over. It just simply call the clone method. Okay. And it's automatically the class with the class actual objects or the implementation class will take up the responsibility of creating the object. Another approach will be creating a prototype registry. That means this registry is nothing but a different prototypes that can be stored there. There can be a list, and they can have like a normal add, remove, add basically, and you can have different fields. You can also to have the particular prototype being removed. Okay. So now this particular class going to be implementing that interface, and that particular interface can be further extended by concrete classes. So they can, instead of clone method, they can have the other things, like they can have clone method and they can have the methods. Those are basically to access the state, because some of the states can be private. So let's see the example of the basic prototype implementation, how we can do that with Kotlin. So in this example, we have a class called data class called user. Okay, fine. Okay, so it has few properties: name, role, and permissions. Okay, and the permissions has a one method functionality checking that whether a certain permission do exist in the list of permissions. The permissions are basically different roles like admin, super admin, regular admin. Okay. So how I going to create the object? So here in the user method, I have it's a data class, so I can use the name or positional argument to create the object, and then I have like this list. In this list, I have put that. Now instead of doing like this, I obviously can use the interface and implement that. Here the prototype is been shown as an example with a function method. So in this function method, what is doing, it's basically storing the registry of prototype registry pattern is shown here. So it's storing the prototype registry in a particular list, right? They have not used a separate class like user registry or anything, but in that they have create user. So if they wanted to get an instance of that particular user, instead of creating that users, they basically make a copy of that particular user. So here, as you can see, here, just like in there, Kotlin has a method that is by default is known as copy. So that is how we can implement, right? So the create user will do what? First of all, it will look into the existing list of the users, and it going to be creating another admin too, and it has passes a role admin. So what going to happen out here? So first of all, in the all the users, it's going to iterate over. It's going to match a role, okay, and then simply it's going to make a copy. And this copy object can choose what are the fields it's required. So it can choose the fields that it need to override in the copy, and then add that into their list. Okay. So here in Kotlin, if you wanted to create a copy of another object by overriding some of the values, you can use simple copy method. So I will take a pause and I will ask if you guys have any question on this. Let me put the code in a single line, single page view. So if you have any question, you guys can ask that. Any question?
I have one question. For the copy method, we have overloaded, means we have used the name. We have overwritten the name function, name variable, right? So
Mhm.
the role and permissions will remain the same for the second user.
Right. Because what is the copy provides, right? Copy provides you the all the fields that are there. Okay. You can choose to overwrite or you can don't choose to overwrite, because here we have not choose to overwrite the name, role, and permission. Okay. So you can choose to copy all that deep copy if you want to, and at the same time if you can also overwrite the things. Okay.
Okay.
Similarly, if you wanted to change the permission, you can change the permission as you are copying things. So like there we have clonable and clone. Here we have the copy method in Kotlin. If you want to create a copy of another object without, creating a new instance and then copy over the fields out here.
Okay, so it is similar as clone method of the clonable function.
Yeah,
in Java.
but it will let you overwrite also the field as you are creating the copy.
So,
Okay.
sir, this is a deep copy, right?
Right.
Okay.
Deep copy means, you say for example, this permission is another permission class, right?
Hmm.
So we cannot say this is a totally a deep copy. It is just basically copy method that you are calling. But if you wanted to override certain permission, then you can also override. Now these permissions, deep copy will be you on the permission also you are making a copy of it. So currently it does a deep copy, but at the same time it's provided option of overriding things that are there.
Okay.
Okay, the fields. So that is the example of prototype upon copying object. Next is the builder pattern. I think we have known about using the builder pattern, right? We have used it in our code. So can anybody tell me what is the benefit of using builder pattern?
We have used in building hierarchies in our project.
But what is the benefit of builder pattern than just simply creating
We
the
can
constructor?
we can reuse it multiple times, and just by passing like we did in this in our project, like with variable, with name, or that kind, we can reuse it.
Okay, we can give it a simple example of hierarchy or codes, right? So in our codes, there are certain fields are not always been populated. For example, it can have some mandatory field and non-mandatory field. Like it can have a metadata, it can have a attribute, it can have like files, it can have other projects, etc. Okay, so those are non-mandatory. What is mandatory is only your project ID, only your title, and only versions, and rest of the things are totally optional. So say for example, I wanted to create a lesson with a metadata. So what I have to do, I have to create a constructor, there I put a metadata. Okay, now I want to create a with attribute, then I create another constructor, put an attribute. Similarly, the third instance I wanted to create with documents, I create a document. So this way what happened, my constructors will increasing in the number of size, and this kind of like lots of variables. And if I wanted to create a single one, like for example we can create that with a data class. Here what happen is you just only putting the value that are necessary, right? You only putting title, etc. You are not putting other things. Now that approach is also basically flawed, because then in your client code you have to write this, right? You have to call the constructor, and you have to also put the value somewhere, and not put, maybe in normal case of Java you put null, 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 but here you don't have to put that. So in that case you can create a builder object which can be implemented as a singleton or inner class of that particular class, right? Nested inner class, and there you can choose to create those objects. Sorry, we choose to create the object with or without certain values. Okay, and then we call the build method, right? And each of the method that we use to set a value, for example, I say title, I will call say this builder, say lesson builder or course builder. Then I call the constructor, and then I call the title, and then from the title, as it's only set the title, then it's going to be setting the value of ID and maybe metadata, and it's returning me the particular value. So let's see how this is done in Kotlin. So the builder pattern, what you have to do for the builder, let's see which are the object that is there. So mail is kind of my object, right, that I wanted to create, and I define this mail within the mail method, and it has like an internal constructor, and whichever is actually required field, rest of them are marked as a optional. For example, 2 is the required field, CC is optional, title is optional, message is optional, important is required too, right? So now, how are you going to create an object of this mail? I'm going to use the mail builder build method, okay? And in the build method, what's going to happen? And some of these fields which are optional, right? We have initialize them with that particular certain default value, either empty string, null, etc. Now, here in the build method, we are calling the main, right? Returning the main. So what we're going to do? It's going to check if the recipient is null, then obviously there is cannot let that object to be created because the recipient is currently done. So here what I'm going to do, here I'm going to be using the first constructor, and I put all the values inside and return it. Or alternatively, what I can do, I can return, I can have an instance of the mail and I can return that also. But here is the new instance object is created and it's returned. So all the values has been used to return this. Now user can choose to create, use messages, use recipient, use CC, use title, etc. as per the need. So those things are only going to be set. So here you have messages that is returning the mail builder. So every functionality that will be there will be returning the mail builder, and then that particular object has been sent, and then the current object, the mail builder object, is written with this, right? So similarly, I can put messages, I can put to, I can put CC, etc. That I can put out here. So now say for example, I want to create a mail object. So what I'm going to choose, I'm going to create an object of mail builder without passing any of the values that is required for the mail object, and I choose, we can choose which are the things that I need to execute or need to pass. So here we are only need passing the particular recipient and particular mail message, right? And then I'm calling build. So then what happen is, first of all, the fields that are there, those fields will be copied over. Whatever fields I have passed, only those fields values will be override. Rest will have the default or blank or zero, those kind of values. Okay. And then when you print out, if that whatever value that is been overrated, that is going to be print out. Rest of the things will have a blank. And this way of creation of object much more user friendly, much more easy. We don't have to overwrite all of the constructor. This we can simply put. So here only we can see the message and the recipient is only change, and CC, you have not set the value, that the CC is blank. So that problem builder resolved. Okay. Now the next pattern if we look into is the factory method and abstract factory. So there is a difference between them. So anybody knows what is the difference between the factory method and abstract factory method?
In abstract factory method, we don't define methods. For example, if we define two classes like engineering and doctor, but and the single class that they are inheriting is like humans. So in humans, we will not define any functions. But for example, degree or certificate, we have function in human class, and that function, that degree function, is inherited by engineer or doctor classes. So in degree class, we will not define that, but it will be inherited in engineering and doctor class, and they can use them by their own methods, like something like that.
Mm, Not very clear. Okay. So what is they are saying about the factory method? It's nothing but it let you create an object, right? Or its subclasses. Okay. But subclasses of different types of the object can be created. Okay. So basically, the class hierarchy be like that. You have an interface as the parent class, like you mentioned, right? And you have like concrete subclasses are there. So with this pattern, what I can do, I can create the concrete subclasses, but instead of having this, logic, if else logic of creation of object as per the business logic, I have this spread across my application. I want to be consolidate that based on our class or a particular function or etc. For example, say what we need to do is we get a raw hierarchy, right, from the GraphQL method, correct? And then based on the hierarchy type, we have to create a CW element. So CW element, we can thought of about our interface and all the child classes like CW unit, CW lesson, CW assessment, CW activity, etc. are our child classes. So if I wanted to create that particular object, right? So what I have to do, I have to just choose the object type, and based on that, I can easily create that particular function, right? So currently, right now, what we do is we just use the same switch statement that is there, so which we are using this pattern and we just creating the object that is there. Do you guys agree? That's an example of factory method. No responses. So let's see in the example, right? Like here, we have an interface in chess field. Right, there are different chess pieces are there, right? One is horse, queen, pawn, etc. Right? Then these data classes are being inherited. The interface being inherited into these data classes, right? Now I wanted to create a queen on my chessboard on a certain position, queen to a5, right? That box I want to place it there. So each of the child classes is a concrete class, right? And they inherited the interface. And then by that, they're also overriding the default values that are there. Okay. And then I have like a function which going to be creating the object. What is passing? It's passing the type notation type of that particular chess piece position and is type of chess piece, right? So then in that case, it's going to return me a chess piece. But based on the type, it's going to be first checking what is the notation to character array that he has converted. Okay. So as a converted into character array, we get Q, A, 5, right? So what is Q? Q mean queen and P mean pawn, right? So queen is being created or pawn is being created. Now here in the queen, the file and rank is the position has been passed. Similarly for the pawn. And if there is like any particular different type has been provided, then we are throwing an runtime exception, unknown piece of that particular type. So we have this factory pattern method pattern we can implement in the wherever we are mapping our hierarchy to different hierarchy CW element, because all of our classes are basically inherited from the CW element class, right? Any question on this?
Can you please show the main function for this particular example?
Yeah, so main function is very simple. Main function is passing the piece type and the position number on the chessboard. Okay. So when that particular function method call is called create piece, and they have been broken down into the type. It is like Q for queen and P for pawn, and then the file and rank, that position is sent into the pieceboard. So here you have the interface. This is the interface that we have. We're going to our factory method is only creating the object of this interface, and then it is inherited into the concrete chain classes. Those are data classes, and they are overriding the value that is there, right? And that value you are passing into by calling the particular constructor.
Okay.
Okay,
Sir, only here we are only using one single method, right?
all right. Only single method.
We cannot use multiple methods if we are inheriting from two different classes.
No, if I wanted to add a third function, third class, or third piece, right, like as a king, then I have to only modify one single place, right? Instead of, I scattered my creation logic everywhere, right? So what problem it solves? What is the factory method is saying? The problem it's solving is that you need to support newer object type. Like example, I need to type separate key. So each change will require a different constructor. Okay? And creation of this business logic within the code in multiple time if scattered, right? So instead of scattering the logic, we are putting the logic in a single method. And if I need to change another type, I can easily support that within the factory method. Now in abstract factory, what happening is it creating your families of related objects without specifying their concrete classes. Okay. So your concrete classes may have many variations, right? Okay. Say for example, one of my concrete class is what? What are the activity and assessments are? Or quiz maybe. What are they? They are all CW path, right? Correct? Correct? Today
Yes.
we have assessment, today we have activity, and also we can have in future quiz or exam, right? So in future when these things are getting expanded, but everybody's parent type is what? CW path or path, we can see, right? So in that case, what happening is you have a multiple variation of the parent type, right? Or the superclass. Okay. And now you have to always have a new change in your creation logic. So then how are you going to create this logic? Should I be aware about all the concrete class? I may not aware about them, right? So in that case, what I can do? Okay. So here you have a parser class. Okay. And in this parser class, what you're finding is it has a method called server property string, list of property string it receives, and server configuration it returning. So it has a mutable property, that is configuration properties are there. So it's going into the property strings from there, and then it's converting into the property object and putting that particular thing into a collection. Okay. And then it basically, so basically what is saying, it has a list of key value pair, right? Here we can see the server configuration port 8080, my server is running, and what is my environment variable is the basically production, right? Now this list I have passed. Now this key and value need to be converted into at object, right? Object type name property. Okay, and that is like a total server configuration that you like to print it out. And from the server configuration implementation class, you wanted to parse property list, you are passing there. Okay, so now today I have these two properties. Now tomorrow I can have like a data with JDBC URL, then I can have mail server URL, etc. I can put anything into the key value pairs, right? Like our path, right? Today there is only assessment and activity, but tomorrow there will be exam and quizzes. So here, what is doing in the particular property method, taking the property, splitting the value, changing into name value pair. When the certain name is coming out, so it creating an int property, it creating a string property. So property here being the parent type. Okay, it may be so in our case it may be an integer property, it may be a string property, or in future I wanted to support a comma separated list properties, right? Okay,
So,
so
what is the in property here?
these are basically concrete classes. Okay, these are concrete classes of your property class. So if I can scroll down, this is my property class, right? Interface property, and it has another unrelated interface, that is the server configuration, and it has a list of properties. So in our case, it may be a CW element being an interface, and within the CW elements, you have at the end paths, right? Now paths is another interface which can have another sub interface activity, not sub interface, rather concrete classes like activity,
assessment?
assessments, exam, and quizzes, right? So now here I can add, today I have integer, and I also have like an string property class, right?
Mhm.
Now if I need to support a new list property class, I can easily support that.
Okay.
Correct? And then server configuration has a separate implementation. So how are we going to be supporting that? How are we going to be writing that? So here I have like a separate class, and here you have one particular function that's taking the property as a string. It has a key value pair. So based on the key value pair, if it is in port, then it's like a int property. Then the corresponding value you have trim and convert into int, and if it's like an environment, then you are making as a string property. Tomorrow it's a list of certain set of IDs, right? That I like to, in my cases, they may be metadata IDs, metadata group IDs coming in a comma separated list, right? So if I say metadata group IDs, then what I can say, I can pass them using a list property. Okay. So difference from that, here is also we have a method, but along with that, we are converting this, putting into another class, another separate class property field. We are populating that, and then we are sending it back. So if we can go back to the particular abstract factory method definition, right? So what is let you produce families of related objects without specifying their concrete classes. So our server configuration class is not aware what kind of property that is it. It's a int property, it's a list property, it's a string property or not. Okay. So the difference between your abstract method is that though we are returning an interfaces, that particular abstract method need to be aware about all the property types that are there, right? And here, the abstract factory that is there, it let you create unrelated classes without knowing the exact concrete implementation of this. So normally, if I need to implement, how are you going to be implementing this in our abstract factory? So what is how we're going to be implementing this? So I have a different variation, right? Like we have given example of. And I have one interface, and that particular interface I can say it's a property factory, right? And then I can say list property factory and string property factory and then integer property factory, right? Okay. And then based on that, I can put my own implementation logic of initialization into those property factory or related types together. And within this particular property factory, right? Property factory. So, say for example, I have one is a property factory, right? Now, along with the property factory, there can be a different kind of factories together, right? But when we are saying this, we are saying that that's like a properties, right? So basic example, I have two related group of classes. What are the two related group of classes? One I can say, one is our hierarchy, another is our path. Both are separate, right? Now, so what I can do, I can create one hierarchy factory, and within that hierarchy factory, what kind of related classes I'm going to create? I'm going to create courses, I'm going to create unit, I'm going to create lessons. And also we have like a splitter. So that's the one group of related classes coming under the hierarchy factory. Another group of related classes are coming under the path factory. So in the path factory, what I can create an assessment, I can create an activity, I can create an exam, I can create an poll or quiz. Okay. So these two are separate, right? Now, say these two classes I have inherited into a main class that is a course factory. Okay. So when I say course factory, I want to create a new code. So these codes can be part of certain paths. This course can be having like multiple hierarchy structure. So using these two interfaces, now what happened is these two interfaces are encapsulating what? This says only I am returning you a hierarchy, but I'm not saying you which kind of hierarchy. Similarly, I say there is like a path. I'm not saying which is the concrete path. So they are only returning the interfaces, and based on the hierarchy and path, I create a course. Similarly, I can create a standalone lesson. So that means my Cosmos hierarchy factory that I can create, which currently can create a course and a lesson, and underneath that there can be different hierarchy combination, path combination, etc. For example, under course I can have certain exams, under unit I can have goals, like that. So the simple difference is that here you're going to have interfaces and sub-interfaces. Sub-interfaces are basically going to group together related class creations, and parent interface will group together a particular class creation that comprises of interfaces of these both two interrelated group of related group of factories. So in our case, our main Cosmos factory, Cosmos hierarchy factory will have two methods. One is class, create class that will create a course, and one will be creating lesson. but lesson and course itself is a hierarchy, and they can have like a multiple paths that are there. So is it clear now, the difference between the two?
Yes.
So now let's complete the abstract factory. Now there are like structural factory. So we're going to cover few of them, and then on the next session we cover the rest and the concurrent patterns. Okay. So we're going to talk about adapter and proxy. Any idea what is adapter, what is proxy?
So in adapter pattern, it acts like an adapter. So
What
we
is
going
adapter does?
basically we are going to means convert the interface of that class into another interface.
Okay. And what is the proxy does?
Hmm.
Okay. Okay. Let's see. So adapter are basically popularly known as a wrapper pattern. Like he says that two objects are there, right? Which are implementing different interfaces. So they have like a different methods, properties, etc. So for example, in our case, we have our client which are calling our a GraphQL API, and there they have represented the hierarchy in a different way, and we represent our hierarchy in a different way. Like we can say it's a course, etc., etc. There the structure is one hierarchy parent, then their children are different hierarchies, then the subchildren are different hierarchy, then their subchildren are different hierarchy. So it's basically one class that is hierarchy that is coming, and they have like a parent-child relationship. But into our domain or Cosmos, it is like a course. Course has splitter, splitter has unit, unit has lesson, and so on, right? So what it basically does in Cosmos is basically we adapt the external data format into our data format, or external data model into our data model. So that basically we wraps the external API, and that changes the data model, that transform the data model and return the response that is being consumed by multiple clients. So example is given. What is that? Like for my external say SOAP service, I'm getting the response in a XML format, right? And on top of that, I create a REST service which wraps the SOAP service and return the result into the JSON format. Okay. So for that, what I'm going to do, I need to write an adapter for the SOAP that will just wrap up and convert one data model or one data type or maybe one data exchange format to another data exchange format. Okay. So it's very popular. So we all know about it. So let's see how in Kotlin we can simply write it. The creation we have completed and open the structural pattern. So first is the adapter one. Okay. So now here we are seeing simple example. We have a cell phone, and cell phone has a charger, and charger has USB type C. Okay. There are other USB type is a USB mini type, right? And between two chargers are not compatible with each other. Okay. Now let's see the classes. So here different functions are saying that it's basically two functions, right? One type to another type it's converting. For example, in our data type, what we have is that they are sending as metadata, and we have like a CW metadata. There we write the two methods. So two method convert words. It converts the incoming metadata to CW metadata format, or it can have like a form metadata, but it converted to CW metadata to their metadata format. So here is the two method is there. Now here you have that USB plug to EPUB plug, right? So first is checking whether the power is true and false, then it's returning a particular object of the plug with overriding has power, etc. Similarly, USB mini to USB mini C, they are converting one object type to the another object type. Okay. And then they have like a user output, which is just creating an object, returning an object, and then it's just overriding the value with certain things. And similarly, it has changing the value with certain things. And so power cell phone is there, its charger has power, so it says I got the power, otherwise no. So here you have the different interfaces. So one interface is representing the power presence as a string format. Another interface is presenting the power as a integer format. So how can I convert from one power to another power representation? So like it's like a boolean, right? Boolean we can represent 0 and 1, or we can represent as a true and false. So that's how the two interfaces are different. So say these two interfaces are exchanging data. So obviously there you have to use the adapter function that they have written, and they are converting one type to another. How they are checking that has power. If the has power of this object, that means USB plug is 1, then they are returning its true and false, and by which they are creating the object and overriding the value of has power by translating from string number value 0 and 1 to true or false. Similarly, other two examples are given. One is the USB type C, where it's taking true and false. And this true and false is what? True and false is there is an enum is there. True and false is what? True, what is true? Enum entry. Okay. That is the power enum entry. True and false. Now, obviously, here the power enum is represented by here power is represented as a power enum, and here the power is represented as a boolean. So when they are converting from one type to another type, two method, they basically saying if it has power is equal to true, then it's true, otherwise it's false. That's how we are translating the value, one value to the another value. Okay. That's how they are creating it. So that's very simple. We know about the adapter. Now let's look into the proxy. What is proxy does? Okay. So it's allowed to access an external object or API, another object or API, and it's control how the object and API can be accessed. Say you are creating a particular object or you are accessing a particular external API, which is time consuming or resource expenditure. right? So we wanted to control that object being created. For example, we wanted to connect to the database, right? Database connection are costly operation. So maybe you wanted to create an idle database connection beforehand, and then you wanted to let it access, right? So another database connection proxy object you can create, which will control how the connection can be open, close, or how the connection, against the connection I can create or execute the query. So all the client is not going to access the JDBC connection, rather than it's going to go via the proxy, JDBC proxy connection for that particular database activity, or calling the external API. Like for example, in a database connection, what you can do, we wanted to lazy initialize a 4 or 5 connection pool beforehand, and that particular connection pool we wanted to use, rather than opening a new connection for each and every request. So what proxy does, there is no actual transformation is happening compared to adapter. Rather, it controls if there is anything is required to accessing the external API. For example, I wanted to call an external API which need to be have added a authenticated request header into the header, right? So when I'm making a call, I just read my configuration properties, and then I add the authentication header. Or maybe I wanted to call the external identity server, get a access token, and use the access token, I make the external call. Okay. And maybe I wanted to also, in the proxy, wanted to store the cache the data, right? And there may be a cache system, a Redis cache or a distributed cache, like cache is there. And that particular cache, I'm going to store the data. I'm going to check before I call the external service whether I have the cache, having the data there or not. And then I'm going to make a call to the actual service. If the value is not there, if the value is written back, I'm going to be storing that particular record that is there. Okay, that's the proxy pattern. Let's see the example of this. So here you have one thumbnail and one URL. These are the external image that is there. So you are creating a data class as a class image, and it has like a byte array, etc. Okay. Anybody wanted to access the image, right? Or the image size, what is doing? It's storing the image, actual image per se. It having the URL, and if anybody wanted to access the image, then it are lazily initialized. So whenever that particular thing is first time is called, it has lazy, by lazy keyword, it's going to be fetching the image from that particular URL and read it bytes and store that bytes and return the what is the byte size. Okay. So now if I run this, how many times am I going to be able to see the log message? Though this image has been called twice. I only see the log message only one, because it has already fetching it only for the first time, and it's lazily initialized this particular block, and it's only storage. So next time when you call it, it's already initialized, so it's not going to go and extract the external API. It can easily automatically get the response back. So this is acting as a proxy, but it's not just fetching the data as it is, it's also involving, also caching and so lazy initialization. Okay. Any question on the proxy? Okay. Let's go to the packet design pattern. Okay. So we normally have like a in during long period of time, right? We have enterprise Java beans, right? And enterprise Java beans has lots of methods like lifecycle methods, other methods are there. If I wanted to use those interfaces to call that. So instead of doing that, we create a facet pattern, right? And using the facet pattern, I provide only simplified method which will only contain the logic or business logic related objects. And rest of the other things was hidden to the clients, right? So facet pattern when you're going to use when a particular object or other set of classes are giving lots of operation that is there, but I'm not interested on those operation. I'm only interested only the business logics or the values or the subset of the operation. Then instead of using that interface that class provide, I create a facet object, facet interface, and the concrete implementation of that. And then I'm going to be using only that of a simplified set that makes sense for my application to use. Okay. So now what is the benefit of this? That I can put into the packet all the initialization logic, all the lookup logic, all the logic that is there, that is to initialize or access that particular object or access that particular data that is there. So clients are not exposed to that. The clients are not need to repeat those, right? And all the dependency, all the configuration and manage within that. Okay. So for example, I have a REST service. I create a REST API packet, and that particular packet will take care of the calling the REST API, passing the authentications, parsing the particular request object, setting the request object, getting that response object, passing that, converting that particular value, and return me the results. Also, it can pass the result and return me only result. For example, say I wanted to look into the user permissions. Okay, so user has a set of permission. It can do read, write, etc. Or read, write, or it can take action of creation and deletion for permissions. And there are maybe 4 or 5 areas when these permissions are allowed. So should I be writing all the code for accessing the REST client, passing the JSON, building the request object? I just build the request object and I get the response object. It is the REST API packet which take up the rest of the responsibility of doing this. And then it also have the responsibility of passing the logic and return me an array of permissions class that I can use, permission object that I can use into my decision whether I will allow the user to perform these operations or not in my business logic. So that's also decouple my clients from the implementing classes, right? Just only I have to maintain the packet integration code, which is basically nothing but a code I'm calling with a certain request object and a response object. Okay. I hope packet is clear to you guys. Let's see a quick example. Okay, so here we have now here we are using Kotlin IO path. We are reading from a path and we are also having like experimental path API. And here we have the opt-in annotation. What does this annotation do? Declare that this particular API or method marker is opt-in. So users are not required. Okay. You can turn it off if you wanted to with this flag. Okay. So now what is it doing? it has a class called server. It has a private constructor, which is int, and it has a companion object with port. On that particular port, it just create the server object with the port. And it has an interface parser, which has a property it reads and return the property object, and property settings, it reads the list of strings and it's written the server configuration. Now this parser has been, now the properties we can implement in different way. We can have the configuration property defined in a YAML file, or configuration properties we can define in a key value pair in a properties file. So here this parser interface is inherited into the YAML parser, right? And in the YAML parser, it not able to read the key and value pairs, so that is not implemented. And also it's not having that particular server parser, so it is not yet been supported. Similarly, you have a JSON parser that is not supported, fine. And then you have a simple class property and a simple class configuration with this particular value. So let's ignore this YAML parser and this thing. This can be implemented specific logic for YAML, specific logic for JSON, etc. That is not implemented, but you guys can implement that. Now here you have server start from configuration. So here they have path, a path location. So from the path, you get a path, and from that path, you read all the lines. So you extract all the lines. After you extract all the lines, you try to read first the JSON parser, all the server lines, or if it is failed, then you read it using YAML parser. Or then you create the configuration object, you get the port, and you returning the particular server that is there. So what is the packet says? If you can recap, the packet says, okay, I have like a external APIs or services. I only want to be provide a very simplified API, right? Start from configuration. That is it. And then from the main server with port 0, start from the configuration, path through the configuration, it will provide it, and there is no specific logic that is there to either passing for a YAML file or passing for a JSON file. It just only provide me not to set individual properties. It just says start from configuration. Within the start from configuration, it reads the path, it figured out what are the configuration, not only port, it can have other configuration also. And from the port, it basically starts it and return this. So instead of having like, depending on these two libraries, read the values, etc., we just have very convenient method, okay, as a start from configuration with the file location. It can be YAML file, it can be JSON file, it can be text file, whatever you implement. Okay. So any question on the packet method, packet design pattern? I think we can, oh, sorry, your voice is, oh, sorry, I may not be unable to see your question, hear your questions. Okay. Any questions you have so far?
We have used creational design patterns, and I am able to judge that in this what I have to implement. I have to use Singleton or factory design pattern. But but I'm not sure about structural design pattern. That when we will use the structural design patterns, how we will come to know that here we have to use structural pattern.
So can you tell me which of the structural patterns are you think are being used out here into our services? We already using the adapter pattern, right? As we are converting from one object to another object.
Yes.
Okay. Similarly, say if I need to connect to an external service, the REST APIs, etc., I can use the proxy one. to add caching if I wanted to. Correct? I can add that. That is already been added, right?
Okay.
Yeah.
So for caching purpose, don't we need a database or anything? We are
No,
removing.
not database. Like for example, here we are caching the configuration that is there, right? Initial cache is there. So that is read from your configuration class. Okay. From your environment variable. You are caching that value. You are proxying that. Anybody wanted to access the global configuration is go to this particular proxy. They are not exposed to all the method of reading it. Okay. And then the packet we can use if we have like different complex methods, and we can simplify it, provide an interface with simplified method that the client can use. I think we are has spent certain time. We can pause here and we can again revisit the rest of the classic design pattern structural one, and then we're going to be look into the concurrent design pattern, and then what are the design pattern we can practically implement it in a microservices. So let me pause the sharing here and stop the recording also.